Okay, here's part 2, number 13. In order to determine the selling prices of products, a baker finds the cost of ingredients and adds the estimated profit, because he wants to make a profit. Remember, profit equals the selling price minus the cost or expenses. For large production products, ingredients costs are often broken down to 3 place decimal fractions of $1 per ounce of ingredients. Total ingredient cost for a cake is 0.076 cents per ounce. You might want to underline that. That does come because that's a rate. The estimated profit is $2.43. Find the selling price of a cake that weighs 2.234 pounds, 16 ounces of 1 pound. So I got to find the selling price, so I'm finding the money. Now they did mention profit, okay? So what do we know about profit? Well, we know that the profit is equal to the selling price minus the cost. And we know what we want our profit to be. We want our profit to be $2.43. Okay? Now the selling price, well, that's what they're asking, so we don't know that, question mark. Minus cost. How are we going to find the cost? Well, there's cost, but it's a rate. So I'm going to go 0.076 over 1 ounce. And I want to find cost, so I'm looking for my money. Now that's all fine and good, but that's pounds, okay? The cake weighs 2.234 pounds. Well, what do I do to get that into ounces? One thing you could do is multiply it by 16. Or, if you want to use ratios, 16 ounces is 1 pound. And we have 2.234 pounds. So I cross multiply and divide that, and I get 35.744 ounces. So that's how many ounces I now have in the ratio. I had to convert those pounds into ounces. You could just multiply it by 16 too. Okay, that works. Then cross multiply and divide, and that is going to be the cost, the total cost. And the total cost ends up as 2.72. You'd want to round. That's not the answer. You come up here. So I had a number. I subtracted 272. I wound up at 243. Pretty sure to find the selling price, the number we started with, we could just add those. Okay? So 2.72 plus 2.43, and that's $5.15. That one's kind of a tough one. Okay, number 14. Gosh. Definitely doable. Inspector measures various dimensions of a part. Using the view of the mounting block shown, find dimension A, B, and C. Okay, now this is kind of hard to see. A is these holes, these little ones here, not the big ones. That's for dimension B. Because A here, and then to the end. From here, the edge, to the end of these little holes here. Okay, so we'll talk about the holes here in a bit. So before I get to the hole from here to here, I can see that that's 3.05. Those are the two arrows, okay? So 3.05 plus, now my holes begin. What's the distance between these holes? It's not 6.78. You got to look. That's these big ones. Look further. There and there it says it's 5.94. But you got to multiply that. Because okay, so A, we had the edge length 3.05, then the holes begin, okay, and they go to the end of A. Now count the spaces, so don't count the first hole. You count spaces by 1, 2, 3, 4, 5, 6, 7. So times by 7. That'll get it done, okay? 5.94 times 7 plus 3.05, 44.63. Don't put a label on it. I didn't give you what the unit of measurement is. You put units, or I guess, okay, if you really need to. Okay, B. Dimension B. That's these big ones here. So there, see, it's at the end of the big hole. So B. Now before I get to the big hole, I have here to here. And that's broken up into two parts. The 3.05 plus the 3.37. Plus, What's the space in between the B holes? That's the 6.78 right there. So plus 6.78 times, and B runs to the last center of the last hole, so I just go, remember, I don't count that as 1. 1, 2, 3, 4, 5. So I multiply it by 5. That's the spaces. You're measuring the distance, okay? The spaces, not the actual holes. So you can easily fix that. You just don't count 1 with the first. You count 1 with the second. So 6.78 times 5 plus 3.37 plus 3.05. 40.32 units. Then C is much easier to see. So you got your 3.57 plus your 5.84 before the holes start, plus the 7.01 times, because I can easily see the spaces there. So 1, 2, 3, 4. So I'll be timesing by 4. Okay. You don't really count the first hole because there's no space before that. So 7.01 times 4 plus 3.57 plus 5.84, 37.45. And that's the last of those problems. Thank you. Okay, 15. I'm not going to read all this. Ventilation air requirements, okay, in cubic feet per minute, okay, ventilation, that's like airflow. An apartment needs 17.5 cubic feet per minute per person. It also needs 0.33 cubic feet per minute per square foot of floor. So here's a floor in my house, think of that as a square. Every one of those I need 0.33 cubic feet per minute to run through my house to keep it properly ventilated, okay? And then the stores the same way, the factory, hospital, office, A and B. These are relatively easy. What's the total ventilation of air required in cubic feet per minute for each of the following items? So cubic feet per minute, cubic feet per minute. 15 employees, that's people. Well, if one person, for every one person we need that much, so if there's 15, we're probably going to take 15 times 17.5, okay? That's going to be our answer, 303.75. Then we're talking area, okay? Square feet in a hospital. So here's the hospital, 0.330 cubic feet per minute per square foot. So I need to take the 0.330 times how many square feet I have. So 23,000, okay? 0.330 times 23,000, 7,590. Okay, so those aren't too hard. 16 is not hard. I'm only going to do one of the 3 employees to save time in the video. It's not hard. A payroll clerk computes the net wages for employees A, B, and C. First off, a net wage is the wage that we received after all deductions have been made. Because you have your gross pay, then a bunch of deductions are made for federal tax, Social Security and Medicare, retirement, health insurance. All payroll deductions are based on the gross wage except health insurance. Health insurance is a constant. Everybody pays $27.18 no matter what. The deductions are shown in the table. The formula used for computing each deduction of the amount of deduction is given for employees A, B, C. One thing you're going to write here, we're not going to figure in overtime. So this guy works over 40 hours. We don't need to do that. Okay? I'm just going to do employee A to save time. Okay? To save time in this video. So first, I need to find the gross pay for employee A. Gross pay is real easy. You just take his hourly rate times how many hours he worked. So $15.25 times 34.25. And this guy then made $522.31. You're going to want to round that to the nearest cent. Then we make 4 deductions: the tax, the Social Security, Medicare, retirement, health insurance. Minus, 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 minus. Now, the only one I know right now is that he's getting $27.18 is deducted for that. Deducted means minus, okay? Then federal tax, employee A, we take 0.1372 times his gross wage. So take that gross wage times 0.1372, and that's how much you deduct for the federal tax. 522.31 times 0.1372. Okay, $71.66. Do that right. Yeah, I did. Okay, $71.66. Then next, Social Security and Medicare. This is for everybody. Everybody's gross wage gets times by 0.0765. So times 0.0765 back to the gross wage. You're always going back to that 522.31 times 0.0765. Okay, $39.96. Okay, then he's got retirement. That's what he gets later, but he takes out of his paycheck. Okay, same for all employees. Okay, so take the gross pay again, times 0.025. So 522.31 times 0.025, $13.06. Then I subtract them, and that's the answer for employee A. Okay. Okay, there's his net pay, $370.45. Now, I'm not going to do B and C because it's just repeat procedure, okay? You take this times this, that's the gross, okay? Now, then you make your 4 minuses, you know that's coming. Now, for employee B, make sure you take, for the federal tax, you take 0.1455 times your gross wage, and then we use these two again for employee B, and then that. And then C, same way. Don't worry about the overtime on C, though, okay? Since these are examples, I'm going to keep moving to save time. Okay, number 17. The amounts of trap rock delivered to a construction site during 1 week, I should say during 1 week are listed in the table. Trap rock weighs 1.28 tons per cubic feet. Find the number of cubic yards of trap rock delivered each day. Round answers to 1 decimal place. You got to find the number of cubic yards delivered. So if you're not sure what you do, cubic yards, there's your rate, okay? So you can put 1.28 tons, 1 cubic yard, yard to the 3rd power. Tons, yard to the 3rd, okay? Well, the cubic yards is what I'm trying to figure out, okay? Then the tons, well, when I line up the tons, I've got 5 different days I need to figure out, okay? So 23.45, we'll figure that out first, then 12.30. Basically, you're just replacing them. You're not adding them all. You just figure them out individually, one by one. Okay, so that times that divided by that is going to be 18.3, 1 decimal place. Pretty much all you do, okay? So yards cubed. That times 1230 divided by 1.28, that's 9.6 cubic yards. And then it's just repetitive. 15.20 divided by 1.28, that's 11.9. 34.29 divided by 1.28, that's 26.8. Because, I mean, you got a lot more tons, so you're going to need a lot more cubic yards. And the last one ends up as 9.8. Really, to be honest, you could just divide that by the rate. But a lot of people would multiply, okay? You would multiply if you had to get tons and you were given the cubic yards. But when you're given the tons, okay, you need to divide those. Okay, number 18. An offset printer bases prices charged for work on the number of pages per job. The price per page is reduced as the number of pages per job is increased. Find the number of pages, that means one side of the sheet, printed if $222.30 was paid at a rate of 0.02 cents per page. Okay, so I have to find the number of pages. Well, what do I know about the pages? Well, there's the rate, dollars and pages. So 0.025, one page. That's what per page means. It's a ratio. Okay, so the actual amount is 220.30. Then I cross multiply and divide, and I get a pretty good size answer of 8,812. Okay. Okay, number 19. A floor covering installer is contracted to install vinyl tile in a building. After measuring and finding the building floor area, the installer determines the number of tiles required for the job. Two different size tiles are to be used. 10 feet square tile, 10 inch square tiles. Each tile covers an area of 0.694 square foot. So that's like this tile here, okay? 10 inches, okay, 10 inches long. It covers 0.694 square feet, okay, because it's square foot in inches, so yeah. A floor area of 3,760 square feet is to be covered with these tiles. And then 14-inch square tiles, each tile covers an area of 1.361 square feet. A floor area of 5,150 square feet is to be covered with these tiles. Find the number of 14-inch square tiles needed, so all I care about is here. So 14-inch square tiles, that's my answer. I don't really do any math with the 14, that's like the title of the answer. Okay, what do we know about the square tiles? Well, each tile covers 1.361 square feet. So 1.361 square feet, one tile. That's the rate, area. Square feet, tiles. Remember, our answer is the tiles, so question mark, and then 5150. Cross multiply and divide that. It's going to be 5,150 divided by 1.361. That's going to be 3,784. Whole decimals don't make sense in that one. Okay, number 20. Given the following data, compute the profit per casting. Okay. First off, I want to write my profit. Profit equals, this doesn't change, selling price minus cost or expenses, whatever you want to call it. So we're finding the profit. Okay, selling price, 264 per casting. We're going to sell 3,500 castings. Now here, these are expenses, they're costs. The die cost, the labor cost, the overhead cost. You can see the numbers on the document. Okay, $983.25 for die, $608.50 for labor, overhead costs $716.75. Now they also have to pay for this, the material. Zinc, they have to pay $1.14 per kilogram, 4,000 kilograms. Aluminum, 85 cents per kilogram, 174.75 kilograms. And then copper, $1.72 per kilogram, 102.5 kilograms. Okay, so selling price. Selling price is easy. $264 per casting, but we're going to sell 3,500 castings. So 264 times 3,500. Okay. Okay, 9,240. That's the selling price. Minus the cost. Now the cost, we got a bunch of cost here. We got $983.25. We've got 608.50, 716.75. Then for the materials, those are rates. So we need to multiply 1.14 times 4,000. Okay. 0.85. I'll go up here. Times 174.75, and then $1.72 times 102.5. Now, all this is added, okay? That's your cost. Now, you can do it all on the calculator. 1.72 times 102.5 plus 0.85 times 174.75 plus 983.25 plus 608.50 plus 716.75 plus $1.14 times 4,000. Okay, $7,193.34. That I might have punched something in wrong, but I just want to speed it up. Okay, you get the concept. Okay, so I subtract, there's my profit, 9240 minus 7193.33. $2,046.67. Okay, number 21. This one's kind of tricky. A bracket shown as part of an aircraft assembly. You don't see the bracket. I think on the assignment they'd show you a picture. It's important that the bracket be as light in weight as possible. To reduce weight, equal-sized holes are drilled in the bracket. Makes sense. Makes it weigh less. The bracket weighs 7 kilograms before the holes are drilled. After 10 holes are drilled in the bracket, the weight then is reduced by 1.4 kilograms. How many more holes of the same size must be drilled to reduce the weight of the bracket to 4.9 kilograms? So how many more holes? That's what you're trying to figure out. That's your answer. Now, obviously, what do I know about holes? Well, 10 holes, 1.4 kilograms. That's a ratio. I'm going to use that. Okay, so 10 holes, 1.4 kilograms. You don't need one. That's a good rate. Holes, kg. Remember, the answer is the holes, so I don't know that. Now, kilograms. Now I need to think a little bit. They need to take some more kilograms off, and I need to figure out how many holes that is. So let's talk about this. It started at 7 kg. Then they subtract 1.4 kg. Then they need to subtract more, okay? And that they want it to equal 4.9 kg. Okay, so let's subtract those two. So after I subtracted the 1.4, 7 minus 1.4 is 5.6 kg minus question mark equals 4.9 kg. So when I did the 10, so when I'm about to drill these holes, I need to know how many kilograms that is that's going to be taken off to get to 4.9. Well, you would subtract 5.6 minus what's 4.9. Well, we could just then subtract 5.6 minus 4.9. That's 0.7. So that would be 0.7 kilograms, okay, that I need to take off, but how many holes is that? So 10 times 0.7 divided by 1.4 is 5 holes. That one's kind of tough. Okay, number 22. This one's easy. Last three are pretty easy. A home remodeler purchases hardware in the quantities listed. Okay, so he buys this. Or this is what this listed. Okay, so if you buy 20 boxes of cabinet hinges, you're paying a total of $60.20. 10 boxes of drawer pulls would cost $18.60. 10 boxes of cabinet knobs 20, 6 boxes 16.20, 12 boxes 22.40. But he doesn't need all that. Here's what he needs. What's the cost of what he needs? Well, I can just multiply these and add, but I need to find out how much just one box would cost. He needs 3, but let's divide the cost by the boxes to figure out what that costs. So 60/20 divided by 20 is $3.01 for one, okay? 1860 divided by 10 is $1.86. What I just figured out is how much one box would cost. 20 divided by 10 is 2. That would be the cost of just one box. 1620 divided by 6, that's going to be $2.70 for one. 2240 divided by 12, that's $1.87. That's how much one of them costs. Okay, so one box costs $3.01, so I'm going to take 3 times 3.01, that's 9.03. I'll write it on here. So again, I pretty much can just divide the cost by the boxes to get how much one costs and times it by 3. Okay, then take 4.5 times $1.86. Okay, that's going to be $8.37. Then $2 for one, well there's 10, so it's back to 20 for that because you needed the same amount of boxes that were here. Then 270 times 2 3/4 or 2.75, whatever, it's going to be 270. Or no, my bad, that's going to be 743. I don't know what I was thinking there. Okay, this divided by this, so it's $1.87 for one. Well, we need 2 of them, so $1.87 times 2 is going to be $3.74. So I add them up, I get $48.57 done. Okay. Okay, number 23. This one's easy. It took a race car 0.8 hours to travel a distance of 135.34 miles. What was the average speed of the car during this time? Average means divide. You take the miles divided by the hours. Miles divided by hours. Miles per hour. 135.54 and then 0.8. And when I divide that, I get something kind of high because we're talking a race car. 169.43 mph. Okay, and then the last one. Find the total hardware get rid of that. Okay, that shouldn't be there. That doesn't make any sense. I don't know how that got there. Series electrical circuits are shown in figure 3-22. That would be here. These are electrical circuits. It looks intimidating. It's not a hard problem. In a series circuit, the total circuit resistance, RT, that means total resistance, equals the sum of the individual resistances. So to find the total resistance of this circuit here, R1, 6.2, plus R2, 1.75, R3, 0.20, R4, R5. And that's going to be the RT, whatever the sum of that is. Current in the circuit I equals voltage E applied to the circuit divided by the total resistance RT of the circuit. I, amperes, equals the voltage in this, and the volts are right there and right there. Okay. So you take your voltage divided by the total number of ohms of all the individual resistors. Resistors are these little things here. Okay. Okay, we need to determine the current, the amperes, the I, in each of the circuits to one decimal place. This is easy, okay? So circuit 1, circuit 2. So the volts on circuit 1, 100. Then we are going to add up all our resistors, RT. That's what it means, the total of all the resistors. 6.2, 1.75, 0.3, 8.35, 0.20. So if I add those all 5 together, I end up with 16.85. And when I divide and round to one decimal place, it's 5.9 amperes. Okay. Okay, let's look at the second one. Okay. The voltage here is 176. Then I add up 10.5, 13.2, 4.2, 0.50. And that ends up as 32.56. And we divide and we get 5.41 AMP for amperes. Okay, got some nasty ones in that packet, some you can handle.